So good morning, everyone. Everyone's hearing? Good? Awesome. So thanks for having me here. Today, I'm going to talk about some dynamic languages. Basically, most of my career I spent programming with those dynamic languages. And so I have the opportunity to put in production code Ruby, Clojure, and Elixir. So I consider myself a kind of a dynamic language person. People joke about dog person and cat person. Happens that I'm a dog person, but I'm also a dynamic language person as well. So Ruby, Clojure, Elixir. Talking about Elixir, there is anyone here that knows about Elixir, have interest about Elixir? Good, a show of hands. If someone of you really wants to write Elixir in production on your day job, it's your luck day. I work for Telnex. Telnex is a telecom company. It's more a communication company where you are building a global communication system on the cloud. And we do Elixir there, and we are hiring. When I say global, like those green dots, they are currently our points of presence. So all these places we have actual points of presence. So we make local calls there, and we are kind of building the company bottom up. So all those places we also have all the legal stuff to be an actual carrier, a telecom carrier, and now we start to build more high-level services. The blue ones, like you can see one in São Paulo. So we hope that next year we have a point of presence to start to operate here in Brazil as well. So if you have interest to help us to build this thing, or if you have building your next-gen killer app that needs global communications at really low costs, please talk with me. So sorry for the digression. Back to the topic. As I'd say, I would talk about 3 languages, and so I need to make a disclaimer here. I try my best to cover basic ideas of each one of those, but so everyone here is on the same page. My intention is to share some of my findings, some of my aha moments, but I do not intend to make an extensive lecture of each of those languages. So I just assume some overall knowledge about some of those concepts. And to be honest, no one can really teach you a single language in 30 or 40 minutes. So let's start with Ruby. It's a long time since I really wrote my some Ruby code in production, but it's a language that still keeps close to my heart. There's Rubies here. Yeah. I kind of imagine, because going through the program, the conference program, I see a lot of talks that talk about Ruby or use Ruby to talk about other concepts, so it's not so surprising. I try to not spend too many time here talking about Ruby, but it's important so everyone here is a common ground to discuss, to make our further discussions. So Ruby is an object-oriented language. It's very a mainstream idea, so I believe I don't need to explain too much. So in Ruby, you can create classes like this greeter class, and classes can have methods that you can call them. So here I create the Obi-Wan and he'd say hello there, like the Attack of Clones. Yeah, this is a bad movie, but it have a really good memes. But Ruby, different from other OOP languages, it takes an extra mile. So here is a number, like 42. In a lot of those languages, you have these numbers are primitive values. But in Ruby, they try the best to make them behave like a real object. So you can recall methods on that objects. You can ask the class of those values, these objects. And like fixed none is the class of integer number. And you can ask the class of the class and the class of class of class. So you have this kind of inception thing. It's funny. Ruby has a very reliance on this duck typing concept. So Ruby is a dynamic language. So you don't really know what the classes, what the parameters, the arguments you're receiving on your methods, what the classes they are until the runtime. And while this looks like a weakness of the language, it's some sort of weakness, but we are able to take advantage of that. And duck typing is just a catchy name for polymorphism. Here is an example that I just steal straight from the Ruby docs, the example of a duck. So I have a duck that knows how to quack and returns a string of quack. And you have a duck recording that knows how to play a sound of quack and happens to know quack, like have this alias. So it kind of answers the same methods of the original duck, right? So if I have a code that receives a duck and make the duck quacks, you can make both duck and recording quack. So it's just, you have an interface here. Of course, both objects need to have this quack method, but it's kind of out of bounds of your code. It's an implicit interface, in fact. So, but as long as both of them answers the same methods, you can work then interchangeably. So it's just polymorphism, but without extra ceremony. Ruby also has the idea of idea of open classes. It's a way that Ruby found to make open extension. So here is fixed none class. As we saw, fixed none is a built-in class, so I don't have access to the code at all. But I am able to create a new method on that, like if it turns true, is 42, and it works like every other method, so you can really open everything. Of course, things can go bad sometimes, like you override some behavior that you don't really intend to, but okay, it kind of works. In the practice, it works. Ruby also become very famous about its metaprogramming capabilities. This is a topic that even not all Rubies are so familiar with because it's really relied to be used by libraries, but it's very powerful. So here I'm not opening the greeter class. Imagine that it's a new implementation. And so this implementation have no methods at all. So when I create a new greeter and say, hello there, I get a method error. But happens that calling methods on Ruby is a dynamic process. When you call something that an object don't knows how to answer, what it calls is another method called method missing. So we are able to override the method missing and inspect what method is being called. And here, if it's calling something that looks like hello, whatever, exclamation point, exclamation mark, I return the hello, that thing. Otherwise, I just do the default implementation of raising errors. So now I have a very convoluted way of doing a hello world, but shows the power of this kind of runtime dispatch. And if you ask if that object knows to answer this hello thing, it says that it doesn't, because this method never exists. So it's just a fake implementation. It's just smoke and mirrors. But of course, you can really go really far with that metaprogramming thing. So it's kind of the same method missing. But now, if that method matches, I open the class, I define the method in runtime, and return their value in dispatch. So what I'm doing here, I'm really creating code at runtime. And it works as before. But if we ask for, after using that method, if you ask if response, it returns true, because now the method really exists on that class. Think about like you have a dynamic implementation and then you cache that implementation. Rails used to use this technique a lot in the past to create dynamic finders. So you have your database calls like find by name, and it create a find query by name. And it was deprecated a long ago for good reasons, but it still is something that's worth mentioning to show this unique feature of Ruby. So as we can see, Ruby is very dynamic. often when people say that Ruby is dynamic, they mean the type system is dynamic. But when I heard about the dynamism of Ruby, I really like to think more about the runtime of Ruby. So it's like the type system is just a small thing. In fact, when you think on running Ruby application, you really think this dynamic thing that you are fiddling with during runtime. It's really powerful, but of course it takes its toll. It's very easy to shoot yourself on the foot. So it's not wonder that we really, as a community of Ruby, we embrace testing techniques of all sorts. So kind of Rubyists become specialists in testing. Testing is not an exclusive topic of Ruby, but if you came from another community, you want to improve your skills on testing, please, I really invite you to take a look on all the material that the Ruby community produce about the topic. And like just an example, today, at the end of the day, Camila will talk about improving our test suite. And I really I imagine that she is a well-versed Ruby developer. So let's change our gears. And now we'll talk about Clojure. So just demographics, Clojure is, anyone knows where to put the parentheses? Okay, if you don't, just ignore them. I make jokes about parentheses because Clojure is a Lisp. So I have to make the mandatory XKCD joke here. But really, the Lisp is the less interesting. It's very interesting. Like, I'm really passionate about Lisps, but it's the less interesting of their features. The big change when coming to Ruby is that I find that Clojure is a functional language. There is a lot of folks, if you ask 100 folks what functional programming really means, you get 101 answer. So here I try to give my one. Just like make put on spotlight the most important features. So here's a Ruby example for you calling a method on for2. When you talk about functional language, you kind of reverse. You don't have any more data that have behavior attached, but you have behavior, you have code that you send data to that code. And also, it's very important how functions work. So here is a function that just increments a number. And here is a function that gets a collection and applies that functional inc to each element of that collection. It returns a new collection. So here I'm showing really is that you can pass not only data to your functions, but you can pass functions to functions as well. And you, of course, can produce new functions. So functions is a first-class thing. And if you look at code, happens that Ruby, you can do that with Ruby as well. So if you do a lot of Ruby, it's not so different. That's because this brackets thing, this syntax, special syntax of Ruby, what's doing, in fact, is creating a special object called block. And the map of the Ruby version gets that object and calls it for each element. So you have the same behavior. And well, you can see that functional programming, this specific concept at least, is just sides of the same coin, are just different ways of expressing the same intention. Of course, some languages give tools to better express one over another, but it's more about the style of programming, of coding, than anything else. Here, just extending the Ruby example with more methods. So have map, select, and reduce here. As the chain of methods, what happens that after each method, you have a new list processed with the method, with previous method, and you are basically transforming that list one step by time. And it's just the same way you do with Clojure. So despite of the name changes, like in Clojure you say filter, and in Ruby you say select, but it's the same behavior. Yes, we are doing the same thing. So if you know how to do that code, this Ruby code is very idiomatic, by the way. So if you know how to do that that code in Ruby, you are basically a functional. You have like half of functional programming already done, and in case of Clojure, you can even use this new this special syntax that chains together all those calls. So it's really like the same, basically the same code. The difference is as data and behavior are separated, you can think that that special syntax just putting things together as long as they're required. Learning Clojure also makes me see that he put a heavy emphasis on data over code. Is really a Clojure mantra of some sort. So here I'm gonna see again that the duck typing example. Here's this def thing is nothing special. Imagine you are just creating a new variable to hold data. So it's doing nothing special. I'm just declaring a map that defines a famous duck and how it sounds. And I make a new variable with a new map of a recording of duck. And happens that both representations share the same value for the same key for its sound. So I can write a function that just really bothers with only that key and returns like our duck typing example. And now I implemented some of duck typing, the same kind of idiom, but in Clojure. But the difference here is when Ruby relies on objects, here I'm relying only on data. And a data-first approach has some advantages, like objects are this opaque thing, so you don't know what this duck new really is. You just know that it is a duck. And kind of the data hiding behind objects is very important characteristic. But happens that most of our code, most of the data that flows on our applications don't need that property. So when you have a data-first approach like in Clojure, it's really easy to inspect what the data really is. And like here, I just printing. That helps a lot with logs. You can just log all the data you want. You can easily serialize all the data you want. You can store it on a file, on a database. You don't know what you are really missing with just working with data until the day comes where you just copy that data on your log, paste on your source file, and just reproduce a production bug without fiddling with database dumps, with anything else. So it's very powerful. It's very simple. It's not really special. It's just working with bare data instead of complex object hierarchies. But despite of qualities of bare data, it's useful sometimes to keep it together with behavior. So different things can work differently. It's kind of the inverse of our previous example, right? Because on the previous example, I have a duck and I have a recording. So I have two different things that should behave on the same in the same way. But now I really want to do the opposite. I want to have different things behaving the same way. So now I can have different things behaving in different ways, but with the same. But the color just need to ask for the same. So it become more clear. So here I define first the contract of that interaction. So here I define a protocol. So if you know maybe Java, let's say, have interfaces, it's kind of look like Java. Like the idea of the interface is just a contract. And you define the data, the thing that the def record is kind of a special kind of map, a map with a tag attached to it, which says that that map is a duck record. And then you can extend that duck thing with your protocol and make your implementation. Now I can make it quack and it will work like before. But the difference here is that we are kind of tying data and behavior again. But protocols are more a powerful way to do this open extension, because if you pay attention on the previous slides, like, let me get back. The protocol could be on one file, the record could be on another file, could even not even have the code at all, and the extend type could be done on a third place, and when you load, everything will just work. And it's kind of the same. It reminds a little about the open class thing of Ruby, but it's much more cleaner because the way it works, it really avoids all those pitfalls about like overriding implementations, existing implementations. So it's a lot cleaner. It's kind of the idea behind Ruby refinements, but unfortunately, Ruby refinements kind of don't get off. So, okay. From the Clojure mindset, it's important to say that records are regarded as implementation detail. So, okay, you have all this dynamic special thing, but really you should avoid to having public APIs that uses records, because remember all previous slides when you talk about the properties of buried data. If you start to use records, every time you want to use your public API, for sake, you have to build these special things. So another mantra of Clojure is like records implementation today, and data always at boundaries. So you keep all the flexibility of protocols, but you still had this boundary where you could just copy and paste data. Clojure has, for metaprogramming, Clojure takes a different approach from Ruby. Clojure uses macros. I talk a lot about this topic on past year presentation here at the conf, but I try to summarize the overall idea behind it. It's easy to think of macros as a kind of a compiler extension. So it's a special kind of function that the compiler of the language will call, passing the code and getting a new code. So it's like a hook you put on your compiler to rewrite your code. So remember that arrow thing that I showed before happens that it's not anything special. It's a macro. It's called threading macro. What it does, it's just rewriting the code. So here is this macro expand is showing what your compiler does for you. So it's just a way to manually debug macros. And here we can see that a macro expand, this threading thing, gives back another snippet of code. So macros is a way to create new syntax. A famous example in the Clojure community is a library where we implemented the Golang feature of Go routines and backported to Clojure. But it happens that we don't need to change the compiler at all. We're just using this macros and importing a new library. You get all new syntax, all new semantics for your language. And a difference between the Ruby approach of metaprogramming and all of this happens at compile time. So it's often faster because all the work was done before you're running your code, and also it's kind of safer because now you don't have like wild things going during runtime. But in some way, as a very powerful technique, so there's a lot of ways to shoot your foot. So the same safety measures applies. Clojure runs on top of JVM. There's also a dialect of Clojure that runs on JavaScript environments as well. So you can run on Node or browsers or the serverless stuff that runs on Node. Okay, but I'm talking most about the JVM part. JVM, we kind of have these feelings with Java, but happens that Java, the JVM, is the most mature, battle-tested, and performer virtual machine that we have today. It's really, it's just-in-time compiler. It's very powerful. Its garbage collector is one of the best of their kinds. It's really state-of-the-art garbage collectors are done in Java implementations. So relying on that, all this environment really is a killer feature of the language, because you can enjoy all this powerful runtime. You don't need to reinvent square wheels. Ruby is famous for this gen-driven design, where basically every problem was previously solved by some gen. So you just import it in your code and use it. But Java is very old and solved a lot of problems as well. So relying on the JVM also gives that kind of power to Clojure. And companies really like Java. So imagine that you're like testing this new fancy database, distributed database, or something like that. I bet you that the default driver for that database is probably written in Java. Companies often start with Java. So it's really good when we not only have the implementation done for you, like in this driver example, but you have an official implementation. So it's really a good thing to leverage. But of course, Java has its costs. The usual ways of running Clojure code incur huge startup times. So people who did a lot of Rails have that problem when you need to run and run your application all day long, and you have to wait seconds, lots of seconds, half a minute to just have a single test run. And in Clojure, you can fall into the same problem because how things are done under the hood. But surprisingly, Clojure, we are not affected too much by this problem. And the reason is because of the REPL. So all this quality, not all, but most of the qualities I talked before, the functional paradigm, the data decoupled from behavior, the way that Clojure was designed was really to make this thing work. So it's more of side effect of, pun intended, it's more of a side effect of making a REPL environment work. So the biggest power, if you ask me what's the biggest power of Clojure, the thing I miss the most when I'm not doing Clojure is definitely their workflow. You often don't write code and then you run like you do with Ruby, but you start a Clojure process and you connect to that process and interact with this process live. So if you are like creating a small code and need to know if it works, you just send to the REPL and get your answer. You need to update some data point to make your model pass. Again, just send to the REPL. Even running your tests is just a REPL command that loads all your code again and run your tests. So you really don't need to have this cycle of killing and launching your Clojure environment again. There's no way to make justice to that without demoing live. Text and slides don't make justice. But as I'm overdue with my prayers to the gods of demos, I would have to skip this one. But please meet me on the hallways so we can talk and I can show some of working Clojure code. So like Ruby, Clojure is dynamic. It's dynamic in its type system, but it's dynamic in the way you work with Clojure. And after working a while with Clojure, I see that their runtime feels less dynamic. Of course, you can do everything you do with Ruby as well. With Clojure, we have all the tools at our disposal. That's how the REPL works, by the way. But just happens that we have more tools, like the way you have macros and the tools for extension. You don't need to fiddle with running code like you need to do with Ruby. So it kind of has these mutable environment that you fiddle with, but just during development time. Then you just compile, ship that code. The code that you ship it is pretty much static in some sense. And then it came to Elixir. Like a lot of people raise their hands, so probably you are waiting for this one. And happens that I didn't write Elixir for too much time. It's about like I would say 3 or 4 months, so it's pretty recent thing for me. So you maybe wonder, oh, I'm learning Elixir, so I have lots of things to say about it. But it happens that Elixir is a functional language, like Clojure. So you know functional language now. If you make that journey as I did, you know already functional language, so you can't skip this one. And Elixir uses protocols as well to make the open station work. So if you know open extensions, it works here as well, like Clojure. And metaprogramming is done via macros as Clojure. So you pretty much know how of Elixir. It's just a matter of knowing the names of stuff. But Elixir has some different thing. Elixir has the idea of pattern matching. So it's a new concept. I didn't present it here yet, so let's talk about it. Here's our duck example again. I promise I will not implement the duck typing example again. I just using the same structure. So I define here a duck, and this is a map with the name and the sound. And this duck is really a binding for that value. And you can like define, like here I have the inverse of that expression. I have the shape of the data. So I say that I have a map with a key sound and some free variable. I never mentioned this sound before. And I make this equal sign duck. The equal one is not the attribution like we have on the other languages. This equal sign is the pattern matching operator. Think about it. It's more like it's really trying to align all that you describe, and if that's true, it returns. So that's why when you make that pattern match thing, it returns the whole thing. It's because it's really more of a logical attribution. So it looks, if it's quintiliteral, reminds a little about SQL. And if you get that free variable, as it matches the previous pattern, it now has the value of that key value. As we match the key value, it has that value. So you can just use it. So it's a really pattern matching is that useful way to kind of, you have this data store and a way to deconstruct that data and grab what you need. And also, what happens when you try to get a thing that doesn't exist on the variable? Like, what happens that things break? Because pattern matching, as I said before, is a logical construct. It's like think about as an assertion about your code. So you make this assertion that your code has that shape and try to get all that matched data. It kind of make this assertion thing kind of make things feel concrete in some sense, because now your code is coupled with the structure of your data. And these have huge influence on the idioms of the language. Again, showing some Clojure. This is really a thing that take me a lot of time to really get it. Clojure is really built around a lot of abstractions. So here I'm mapping the ink like this, that past example, but I'm mapping over a new value. So new is abstracted as an empty thing. So new really implements all the protocols necessary to operate as a collection. And when you map over nothing, you get an empty collection. So things just works. When you do the same, the equivalent code in Elixir, what happens is that things break. So really, but here's the interesting part. Look at the error. The Elixir error mentions protocols. So we have the same tools that Clojure have, and Clojure uses protocols to implement that abstraction. So, but Elixir doesn't. So it's not something about the tools you have at disposal, because Elixir has all the tools, but it's more about the design guidelines of that language. The consequence of that is that Clojure really feels very concise, because as it's a lot about abstracting. In my experience, Clojure tends to be much more concise. And when you compare it side by side with Elixir code, Clojure has a lot less code, like half the code at least. And Elixir is very concise as well, so it's really astounding to find that thing. But why Elixir choose to be the way it is? Happens that Elixir is hosted as well, but it's hosted on the Erlang runtime system. And it tries to follow all the guidelines principles of Erlang. Erlang has this idea of failing fast. So if a thing is strange or possible bad, it's better to really, or you address it explicitly, or just break as soon as possible. So in your example with the new thing, you have that chain of calls. If the first thing is new, you just pass it forward. And this may be your intention, but maybe not, and things will break badly. And on the Elixir, it just fails as soon. And maybe probably some of you that already look at Elixir or Erlang heard the let it crash. And let it crash is that philosophy, so break as soon as possible. It's not to say that it's not to handle no failures. So please, if you're making an HTTP call and you receive like 500, 500s are pretty then expected, so please handle it. But you have something really that you don't expect, you can just, you don't need to recover, just let it break, because then you give a chance to runtime to handle it gracefully. It's a very big topic talking about the Erlang environment, so I really strongly recommend to attend Renan's talk tomorrow if you want to learn more. Renan's that guy here. People may know him as Mulhouse. Now that makes some more sense for you guys and girls. So the other big thing about Erlang is the idea of OTP. OTP, people talk about OTP. I took some time to understand what OTP is. But it happens that OTP is just a bundle of libraries, patterns, and practice around how to build systems. So it's more about a system design, a system thinking mindset. So it's really interesting that learning more about Elixir make me a better developer in terms of learning about how to build those systems. And it just happens to be on Erlang, but of course you can apply all the lessons that you learn on outside Erlang. So I've just showcased very fast a case that we had at Tonix a couple of months ago. Imagine that you have a service that handles requests, and to serve those requests, it touches a cache. The cache is updated by other services that I just omitted for brevity. And originally, that services are like, you have a lot of instances of those services, and you have an Nginx in front of those services. Load balancing, dispatching load balancing, requests to each of service, and all those services uses a Redis instance. Redis is a key store database. Man, if you use, when you thought about rewriting that in Elixir, what happens is that we have all the tools to describe all this system that has a lot of moving parts, different moving parts, into a single Erlang monolith. Oh, I'd say the damn word, monoliths. Because Elixir and OTP, Erlang and OTP, has the various concepts about processes, and OTP has the idea of chain servers. So what is really you can create mini servers inside your runtime. So you use that to model the dispatcher, the load balancing. We have a pool of other servers inside to deal with concurrency. You can use ETS, which is library bundled together with Erlang, which is just a key value store, and you basically model all the things that I showed you before. And well, if you pay notice, I basically say most of the things I say that I like in Elixir is really that I like Erlang, and that's the best thing for me of Elixir. The power of Elixir is making Erlang accessible. So, like, given our context that after both Ruby and Clojure, language-wise, I get better matching, but language-wise, you don't have so much new stuff. So really, the biggest benefit is being able to use your Erlang ecosystem. Well, now what? So I hope that you see all those languages, and in the end, they have a lot in common, and you can, of course, learn some new stuff here and there. And your mileage may vary. If you have different background in different languages, probably you can reach different concepts and different points of views to understand how your programs really work. But a last thing that I also learned from Clojure is the idea of decomplecting, so I like to share that. This, I believe, is the original code from Richiki, which is the creator of Clojure. Decomplecting means converting entangled, braided, intertwined, twisted software into layered software. So the idea of decomplecting is getting this big, massive thing, breaking it apart, and recompose that. So it's basically what we did with our knowledge about languages. We break down Ruby and recompose Clojure. And we break down Clojure and recompose in Elixir. So really break down your stuff, recombine anew, and use that to learn a lot of new languages. And I hope that everyone enjoyed it. Obrigado.